In this video, let's go ahead and practice evaluating expressions and identifying equivalent expressions together. So in questions 1 through 4, let's go ahead and start with just using each of these different values for our variable to go ahead and evaluate the expressions. We're going to fill in this table that we have here, and we're going to make sure we show some detailed and logical thought process or show some detailed work here. All right, so for this first one, for number 1, we have this expression of negative 3x plus 5, and let's go ahead and take a look at what our x values are. Looks like we have 5 different x values that we're going to try substituting in. We have negative 3, negative 1, 1, 3, and 5. And so we have basically 5 different little expressions to solve or evaluate. Let's start with this negative 3 and substitute it in for x and give that a go. So, all right, so I'm just going to go ahead and rewrite our original expression, but I'm going to go ahead and substitute in negative 3 in for x, right? Just like this. And then let's go ahead and evaluate it, right? So negative 3 times negative 3 is positive 9. Then we have 9 plus 5, and that's going to be equal to 14. So when x is negative 3, we know the value of this expression is equal to 14. But let's go ahead and try this again, right? Let's go ahead and say, let's take this original expression, but this time we're going to evaluate it, but we have a different value here. We have negative 1, and we'll go ahead and add 5 on afterwards. So negative 3 times negative 1 is going to be 3, and then 3 plus 5, that is going to be 8. So if x is negative 1, then this expression would be equal to positive 8. All right, what if x is positive 1? Well, we'll take this 3 and multiply it by 1. Hopefully you're kind of getting the hang of this, just kind of repeating the process with different x values. Negative 3 times 1 is going to be negative 3. Then negative 3 plus this 5 is going to be equal to positive 2. What about when x is equal to 3? So let's go and take this negative 3. We're going to go to multiply that by this positive 3 this time, and then add on 5 afterwards. So negative 3 times 3 is going to be negative 9. Negative 9 plus this 5, that's going to equal negative 4. So when x is positive 3, we know the expression is equal to negative 4. All right, one more time for this problem. Let's go ahead and say we have this negative 3. Let's go ahead and this time substitute in 5 for our variable. And so if we have negative 3 times 5, that's going to be negative 15. And negative 15 plus this 5 is going to be equal to negative 10. So if x was equal to positive 5, the expression would be equal to 10. All right, let's check out another one together. In number 2, we have this expression of negative 2/3 x minus 2. We're going to go ahead and evaluate this expression. Let's see, we'll do it for the value of x, and we have these 5 different values of x that we're going to try this for. Okay, so same idea as before. Let's go ahead and take our original expression. I'm going to take this negative 2/3. And let's go ahead and multiply this by what we have in for our variable each time, right? So I'm going to go ahead and take this as our expression, and we're going to keep swapping out x here. For this first one, we're going to say x is going to be negative 9, right? So if we go ahead and just take a look at this multiplication first here, I notice it's a negative times a negative, so it's going to be a positive, and then this 3 and 9 can cross cancel, so it's going to be 1 and 3. So 2 times 3, that's going to be equal to 6. So we're going to have 6 minus 2 here, and then 6 minus 2 is going to be 4. So if x is negative 9, then our expression is going to be equal to positive 4 here. All right, let's take our expression again, but this time let's take negative 3 and substitute it in for x. So let's go ahead and write this negative 3 right inside the parentheses here. So let's go ahead and multiply this negative 2/3 times negative 3. Again, a negative times a negative is a positive, so we're going to have a positive value. And then this negative 3 is just negative 3 over 1. So again, we can cross cancel these 3's and make them 1's. Then 2 times 1 is just going to be 2. So if we go ahead and multiply this out, we're going to have 2 minus 2, and that's going to be equal to 0. Okay. Again, if you need to do some additional side work to calculate these parts, go ahead and do so. Or if you can cross cancel in your head, feel free to do so. All right, next, x is going to be equal to 3 now. Let's go ahead and substitute in 3 right over here. So if we go ahead and write 3 inside here, this time we have a negative times a positive. So the answer is going to be negative here. But just like in the last expression, the 3's are going to cross cancel to make 1's. So we're going to end up here with negative 2. Because it's negative 2 times 1, and then minus 2 here, right? So what's negative 2 take away 2? That's going to be negative 4. So if x is positive 3, this expression will be equal to negative 4. All right, now x is going to be positive 9, so let's go ahead and substitute in 9 right over here for x. This is going to be similar to when we plugged in negative 9, but this 3 and 9 will cross cancel to make 1 and 3. This time we have a negative times a positive though, so it's negative 2 times positive 3. That's going to be negative 6. So we're looking at negative 6 take away 2. and that's going to be equal to negative 8. So if x is positive 9, this expression would be equal to negative 8. All right, one final time here. Now x is 15. Let's go ahead and plug in 15 in for x. We'll go ahead and substitute in here. Let's see, we can cross cancel here nicely again. 15 is 15 over 1. The 3 and 15 can both divide by 3, so we'll get 1 and 5, just because their GCF is 3. And then we have negative 2 times 5, which is going to be negative 10. So we're looking at negative 10 minus 2, and that's going to be equal to negative 12. So if x is 15, then the expression would be equal to negative 12. All right, let's check out number 3. For number 3, we have a different type of expression. So in number 1 and 2, actually those are more, we can call those linear expressions. If you know, that means that if we were to graph this type of function later on, we would get a straight line. But number 3, this one changes a little bit. Notice the exponent here. This is called a quadratic expression. So this one actually, if you graph it later on, you'll see maybe in algebra 1, that you'll get a parabola shape for this. So just giving you some exposure so you can kind of see what kind of patterns we have here, so you get to be a little more comfortable with them. Let's see here. We have our value of x, and we're going to be using these different x values of negative 2, negative 1, 0, 1, and 2. So let's go ahead and write our original expression here. We're going to have 2. We're going to multiply this by something squared minus 3 times something, and then plus 1, right? This is kind of like going to be our template we're going to keep using here. So first up, x is going to be equal to negative 2. So in this case, we're going to substitute in negative 2 in both of these locations. So these are going to take a little bit more work, so just make sure we know our order of operations as well. First things up here, let's go ahead and take care of the power, so negative 2 to the second power here. I can actually highlight these if that helps. So negative 2 squared is going to be positive 4, so it's going to be 2 times 4 minus 3 times this negative 2 plus 1. And based on order of operations, we would do this multiplication, but then afterwards we would do this multiplication. So because they're both multiplication, let's just do them at the same time here. 2 times 4 is going to be 8, and it's going to be taking away a negative 6, which is the same thing as adding 6. So I'm going to write plus 6 instead of minus negative 6. And here we have just a couple addition problems. So I'm going to do this whole step at once. 8 plus 6 is 14, plus 1 is going to be 15. All right, so if x was negative 2, our expression here would be equal to positive 15. All right, let's go ahead and try this again, but this time x is going to change to negative 1. So let's go ahead and substitute that in both of these locations. Let's go ahead and plug in negative 1 here and substitute negative 1 here. Just like we did earlier, once you get the hang of it, it should get a little easier. So negative 1 to the second power is going to be positive 1. So we really have 2 multiplied by positive 1 minus 3 times this negative 1, and then adding on 1 afterwards. It's going to be very similar to the previous one where we have 2 multiplications. So we can go do those at the same time. So 2 times 1 is going to be 2. And then it's going to be taking away a negative 3, which is just adding a positive 3, then plus 1. And we just have all addition here, so we know it's commutative, and we can also just add them all together at once here. So 2 plus 3 from left to right is going to be 5, plus 1 is going to be 6. So if x is negative 1, then this expression would be equal to positive 6. All right, this time x is going to be 0. Let's go ahead and substitute in 0 into both of these locations. Go ahead and plug in 0 here and 0 here. Let's go ahead and just follow these order of operations. So 0 squared is just going to be 0. So we're going to have 2 multiplied by 0 minus 3 multiplied by 0 plus 1. Feel free to use dots or parentheses here, up to you really. I'm just trying to stay consistent, I guess. So then let's go ahead and do both multiplications here. So we're going to get 2 times 0 is 0 minus 0 plus 1. 0 minus 0 is just going to be 0, and 0 plus 1 is going to be 1. So this expression will be equal to 1 if x was equal to 0. All right, for a fourth time here, x is going to be positive 1, so let's go ahead and plug in positive 1 into each of these locations. We plug in 1 here and 1 here. Let's go ahead and just evaluate this. So start with the power here. 1 to the second power is just going to be 1. So this is going to be 2 multiplied by 1, minus 3 multiplied by 1, and then plus 1. It's going to take care of both multiplications, so this one and this one. So 2 times 1 is going to be 2. 3 times 1 is going to be 3. So we're looking at 2 minus 3, then plus 1. We can just go from left to right here. So 2 minus 3 is negative 1. The negative 1 plus 1 will get us to 0. So looks like if x is 1, this expression would be equal to 0. All right. Looks like I'm running out a little space here, so what I'm going to do is just take this and just make it a little smaller here so we have a little bit of space to fit this last one in. I know you can't do that, so if you need some extra paper, just put on a separate piece of paper, unless you write pretty small. And I'm going to go ahead and do this last one here. And let's see, we're going to go ahead and say x is going to be 2 now. So let's go ahead and plug in 2 into this expression. Let's go ahead and evaluate this. 2 squared is going to be 4. So we're really looking at 2 multiplied by 4. And then minus 3 multiplied by 2, and then we're going to add on 1 afterwards. Let's go ahead and take this multiplication and this multiplication. So 2 times 4 is going to be 8, and then 3 times 2 is going to be 6, so it's 8 minus 6, and then plus 1. Then just going from left to right here, 8 minus 6 is 2, 2 plus 1 is going to be 3. So we can see that the value of this expression is going to be equal to 3. Let's go ahead and just size this down just a little bit so it's more consistent with the rest of what this looks like. All right, let's try one more of these types of problems. For number 4, we have this expression that looks like this, negative 3x squared plus 5x minus 8. Notice how this one's similar to the last one where we have this to the second power. This one's also going to be a quadratic expression, except this time if you were to graph it, it would look like a parabola that is upside down. And that's just because we have this leading coefficient that's negative, which you'll learn more about later. But if you see a negative in front of the term that is raised to the second power, it's going to flip that parabola upside down. So what x values are we going to be using? Well, first it looks like we're going to be starting with negative 4, then we're going to try negative 2, 0, 2, and 4. All right, so let's give this a go. We're going to be substituting in some different values here. So let's do negative 3 multiplied by something squared plus 5 multiplied by something. And then let's go ahead and take away 8 afterwards. So this is going to be the template we're going to use. And first up, we're going to be plugging in negative 4 into each of these locations where x was to go ahead and evaluate, right? So let's go ahead and do that. So if we go ahead and use the order of operations here, it's going to be very similar to the last one, but negative 4 squared is going to be 16. So it's going to be negative 3 times 16 plus 5 times negative 4, and then minus 8. Now we have 2 multiplication problems, so negative 3 times 16 and 5 times negative 4. So negative 3 times 16 is negative 48, and then 5 times negative 4 is going to be negative 20, and then we're going to go ahead and take away 8 afterwards, right? So negative 48 plus negative 20 is negative 68, right? And negative 68 minus 8 is going to be negative 76, so I think it's going to be negative 76. So if x was negative 4, I think this expression would be equal to negative 76. All right, let's go ahead and try this again, but this time x is going to be negative 2. Let's go ahead and substitute that in both of these locations where x was. So negative 2 here and negative 2 here. Let's start by evaluating the power here. So negative 2 squared is going to be 4. So we have negative 3 times 4 plus 5 times this negative 2, and then take away 8 afterwards, right? So we have 2 multiplication problems right here and right here. Negative 3 times 4 is going to be negative 12. And then 5 times negative 2 is going to be negative 10. So we're going to go ahead and add negative 10 here, and then take away 8 afterwards. Now let's go ahead and just go from left to right here. So negative 12 plus negative 10 is negative 22. Negative 22 take away 8 is going to be negative 30. All right, so that's going to be the values of this expression when x is negative 2. All right, so let's go ahead and do this again, but this time x is 0. This one's one of my favorites just because it's so quick. In the future, you can hopefully just know that expressions like this will just end up being this constant term at the end, just because all the other terms will multiply by 0 here. But just being very clear here, hopefully 0 squared is going to be 0. So we have negative 3 times 0 plus 5 times 0, and then minus 8. So of course, this will become 0 and this will become 0. And you can see here that'll be 0 plus 0 minus 8. And then if we go ahead and just go from left to right here, 0 plus 0 is 0, minus 8 is going to be negative 8. So if x was 0, the expression would be equal to negative 8. For a fourth time here, this time's x is going to be 2. So let's go ahead and plug in 2 in for x. Evaluating the power here, you're going to see 2 squared is going to be 4. So we're looking at negative 3 multiplied by a positive 4 plus 5 times a positive 2, and then take away 8. All right, so we have 2 multiplication problems right here and right here. Negative 3 times 4 is going to be negative 12. And then 5 times 2 is going to be 10. So we're going to add 10 and then take away 8 here. So negative 12 plus 10 is going to be negative 2. Negative 2 take away 8 is going to be negative 10. So this expression would be equal to negative 10 if x was positive 2. All right, so I'm running out of space here. I know you can't do this, but feel free to take some scrap paper to go ahead and continue working and put your steps down. But I'm gonna go ahead and just make some space here and go ahead and do this one more time. All right, so this time we're gonna plug in 4 in for x and just evaluate one more time. Hopefully it's getting a lot smoother. So we're gonna have negative 3 multiplied by 16 plus 5 multiplied by 4, and then take away 8. Okay, so we have two multiplication problems here and here. Negative 3 times 16 is going to be negative 48, and then 5 times 4 is going to be 20, and then take away 8 here. From left to right, negative 48 plus 20 is going to be negative 28. Then this negative 28 minus 8 should be negative 36. Okay, so this would be our value of the expression if x is 4. And I'm just going to go ahead and make this a little smaller so hopefully it looks more consistent like the rest of the work. All right, let's move on to some different types of questions here. For questions 5 through 8, we're going to be selecting all. So that means there could be more than one correct answer here. We're selecting all the expressions that are equivalent or are the same or equal to the given expression. So you can see here, this is the given expression or the one that we're starting out with, that we're comparing all the other expressions to. It says make sure to simplify each expression fully to do so. So every expression needs to be simplified. Then verify we've chosen the correct expressions by substituting a hypothetical value. So you get to choose a value for x afterwards. Okay. Keep in mind that you want to avoid saying that x or the variable is equal to 0. You also want to avoid x equaling 1 here, just because the identity property of addition and the identity property of multiplication can make those a little bit tricky, right? You want to stay away from those. Maybe just use x equals like 2 or 3 or 4 or 5. Those are all pretty safe numbers to use. All right, so let's start off with number 5 here. For number 5, I'm not going to rewrite everything as a sum. I'm actually going to just kind of hopefully practice doing this without doing that. But the distributive property is going to go first, just because we're multiplying here. So if we go ahead and do this, this would be what, 4x, and then it'd be plus 10x. Then it would be minus 4 plus 1x, and then minus 1, right? That would be this expression here. If you go ahead and combine some like terms, 4x plus 10x is 14x, 14x plus 1x, that's going to be 15x here. So we're looking at 15x when you combine those terms. And then if you go ahead and take this negative 4 minus 1, that's going to be negative 5. All right, so I'm just going to go ahead and highlight our kind of our original expression here. So this is the original, and we just simplified it to being 15x minus 5. So we're going to now go ahead and see which ones of these expressions is equivalent to 15x minus 5. Right. So right off the bat, though, I think it's important to see that these are not like terms, so you can't combine them. If you did combine them and say 15x minus 5, and you accidentally said this was 10x because you subtracted 15 minus 5, then you might have thought D was correct here. But notice that D is not going to be correct. If you used x equals 1, hypothetically, you might have thought that this works because 15 times 1 minus 5 is the same thing as 10 times 1. So you want to be careful of that. If you check that x equals 2, this would be equal to 25, and this would be equal to 20. So you can see that doesn't work here. All right, so just making that very clear why you can't combine also these coefficients and constants here, right? That's a big no-no. So if we look at answer choice A, we have 3x plus 8x, that's 11x, plus 4x, that's going to be 15x. So it's going to be equal to 15x here. And then we just kind of have this plus 5 hanging out, so we're going to write plus 5 here. So these two expressions do look very similar, but notice that we have a difference and we have a sum here. So it's close to being the same thing, but it is not. All right, for B, let's go ahead and distribute this 5 to both of these terms in here. If we do that, we're going to end up with 15x minus 5. Now compared, do these look like they are the same? They do indeed, so let's go ahead and say this does work out as well. For letter C, looks like we have a couple distributions to make here, so let's go ahead and distribute here and here, as well as here and here. So both of these we can do at the same time. If we go ahead and do that, we're going to get 6x minus 2 plus 9x minus 3. And then if you go ahead and combine 9x and 6x, that's going to be 15x. And if you go ahead and combine this minus 2 and minus 3, we're going to get minus 5 here. So compare this 15x minus 5 to this 15x minus 5, and it looks like these are indeed equivalent. Something else you can kind of notice here is that here we had this 3x minus 1. There were 5 of them, but over here notice how we have 3x minus 1 and 3x minus 1. There are 2 of them plus 3 more of them, which does make 5 of them. So if you see that pattern in the future, that could save you a little bit of time as well. All right, let's check out letter E. For letter E, we have to go ahead and distribute this -2 to both of these terms inside here. So if we go ahead and do so, that's going to be positive 12 plus 10x minus 17 plus 5x. If you go ahead and combine 10x and 5x, that's going to be 15x. And then if we have this 12 minus 17, that's going to be -5. So we can write plus -5 or just minus 5. You can see here that this expression, when it's simplified, is equivalent to this one over here. So we know that this one is equivalent as an expression. Now to go ahead and verify this, let's go ahead and make up a hypothetical value. I'm going to say let x equal 2. Right, hypothetically, and let's see what values we would get here. Now, I'm not going to go ahead and write them, but I'm going to go ahead and talk you through this. Take this x equals 2. If we plug in 2 into our original expression here, what would we get for our value? Well, let's just say the original here is going to be this one right here. Of course, you could plug it in right over here, but for this original one, I'm just going to plug it into the simplified one, right? So 15 times 2 is going to be 30. 30 minus 5 is going to be 25, right? So the original one's equal to 25. So does this work for over here? Well, let's see. If you plug in 2 here, 3 times 2 is 6. 6 minus 1 is going to be 5. 5 times 5 is also 25. So that works as well. If you take this 2 and plug it in here and here, notice what's going to happen. This will be 6 because 3 times 2 is 6. Minus 1 is 5. 2 times 5, that's going to be 10 here, right? And then if we plug in 2 here, 3 times 2 is going to be 6. 6 minus 1 is going to be 5. Then 3 times 5 is going to be 15. So 10 plus 15 is 25 as well. Finally, if you plug in 2 here into this final expression, you're going to see what's going to happen. So 5 times 2 is 10. So we have this -6 minus 10 is going to be -16, right? So we have -16, and we also have this -2 in front. So if you multiply those, you get positive 32. And then you also have to take away the 17, and then you're going to add this 5 times 2, which is going to be 10. So 17 take away from 32 is 15. 15 plus this 10 is going to be 25 as well. So you can go ahead and obviously plug them into the most simplified expression, but that's obviously much more efficient. But if we want to check that we didn't make any mistakes, we would plug these into the original expressions just to verify that these are indeed all equivalent. But that's kind of the power of the algebra, right? If we can simplify the expressions and we do it correctly, then you don't need to verify into the original one. But we're just practice checking right now to just make sure we understand how everything works together with the order of operations, with substituting, and as well as simplifying algebraic expressions. All right, let's try another one. For number 6, let's go ahead and see if we can simplify this thing here. So let's go ahead. Looks like we don't have to distribute, which is nice. Let's see, what's 2y plus 2y plus 2y? So that's going to be 6y's here. So a total of 6y. And then it looks like we have a -3, a -3, and a -3. Again, I'm not rewriting it as a sum, but feel free to do so. You could write plus -9 or just -9. So here's our original expression just to keep it super clear. And then this is the most simplified version of the original. Right away, I like getting rid of an answer choice that doesn't make sense. So if you accidentally said you could combine these like terms, they're not like terms, so you can't do that. So let's get rid of C, all right? And let's go ahead and now try the other one. So A, you can go ahead and distribute here. If we go ahead and do so, we'll get -6y plus 9. Ooh, this one's very close. However, these are opposite coefficients and these are opposite constants. So this is not going to work for us, right? Next, let's go ahead and try B. Looks like we have 2 distributive properties to do here. So let's go ahead and distribute the -5 to both of these and the 8 to both of these. Okay. -5 times 2y is going to be, let's say, -10y. And then we're going to write plus 15. And then plus 16y. And then minus 24. Combining -10y plus 16y, that's going to be 6y. And then combining 15 minus 24 is going to be negative 9. So you can see right here that this 6y minus 9 does match this one here. So as long as we did everything correctly, these must be equivalent. All right, D is kind of nice because we don't have any distributions. So negative 10y plus 16y is going to be 6y. And then this negative 5 minus 4 is the same thing as negative 5 plus negative 4, which is going to be negative 9. So you can see here this is also equivalent to this 6y minus 9. So that one also works. All right, for letter E, we have a bunch of little terms here. So 1y plus 1y plus 1y plus 1y plus 1y. There's 5 of them, so we can say that's going to be 5y. We already know this is wrong, right? And then 5 plus 4 is going to be 9. So it's going to be plus 9. So not only is our coefficient wrong, but our constant term is also wrong here. So this one is not going to work. All right, now to verify, I'm just going to use the same value that I used before. Using x equals 2 is perfectly fine. So let's go ahead. If we just plug this 2 into the original expression here, we have 6 times 2 minus 9. That's 12 minus 9. That's going to be equal to 3. All right, so let's see about these other ones if we get 3 as well. So if we plug in this 2 here and here, let's see what happens. 2 times 2 is 4. 4 minus 3 is going to be 1. So we have negative 5 times 1. That's going to be negative 5. If we plug it in here, 2 times 2 is 4. 4 minus 3 is 1. So we have 8 times 1. And then 8 times 1 is going to be 8. So let's go ahead and say negative 5 plus 8. That's going to be 3. So that's what we had earlier, right? When you plugged it in here, we said this was equal to 3. So this one also matches. One more time, take this 2 and plug it in here and here. If you go ahead and multiply, negative 10 times 2 is negative 20. 16 times 2 is going to be 32. You still have this minus 5 and plus 32 and minus 4. Let's see, negative 20 minus 5 is negative 25. Then negative 25 plus 32 is going to be 7, right? And 7 minus 4, that's going to be equal to 3. All right, so again, just kind of like mentally verifying that, but if you needed to write it out, go ahead and write it out. But I think it's good to just make sure that everything does check out here. Let's go with number 7. For number 7, let's go ahead and simplify this thing. There's no distributions to be made here, so we have 1x, take away 5x. That's going to be negative 4x, right? So negative 4x. And then we have 5 minus 6, which is going to be negative 1. Negative 1 minus 9 is going to be negative 10. All right, so this one wasn't too bad, hopefully, to simplify. So here was our original. Here's a simplified version of that. All right, let's try a few out and see how we do. Let's see if we can identify one where if you just incorrectly combined like terms, we would get that. So what's negative 4 minus 10? That's negative 14. Yep, it looks like this one would be that one if we accidentally did that. So let's go ahead and get rid of E right away. And let's go ahead and start simplifying these expressions. So 2 times 2x and 2 times negative 5. That's going to be 4x minus 10. It's so close. It's just that we have a negative coefficient and a positive coefficient. So we know that these cannot be equivalent to each other. B is actually really nice just because this expression is actually identical already. So that one's really a nice little freebie. We don't have to do anything there. For C, let's see, we have a negative 1x and a negative 1x and a negative 1x and a negative 1x. If you go ahead and combine all those negative 1x's, surprise, surprise, we do get negative 4x and a negative 2, negative 2, negative 2, negative 2, negative 2. There's 5 negative 2's, which makes negative 10. So you can see this does match what we had over here. So this is also equivalent. Finally, negative 2 times 2x and negative 2 times 5. First, we're going to get negative 4x, but then we're also going to get negative 10 here. So looks like this expression also matches this one that we had over here. So this one also works. All right, let's go ahead and verify and let x equal positive 2. Let's plug this into our original here. So let's see, negative 4 times 2 minus 10. This is going to be negative 8 minus 10. This is going to be negative 18. So we're looking for negative 18 here. If we plug in 2 over here, negative 4 times 2 is negative 8, minus 10 is negative 18, so that one works. If we take this 2 and plug it in here, 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 and here, that's going to be negative 2, 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 and negative 2. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 negative 2's does make negative 18. And finally, taking this 2 and plugging it in here, 2 times 2 is going to be 4. So we have 4 plus 5. That's going to be 9. And 9 times this negative 2 is going to be negative 18. So everything seems to check out here. All right, one last problem for number 8. Looks like we have this original expression here. We have 2 distributions to make here. So if we go ahead and distribute this negative 6 into this parentheses here to both terms, and then we have another distribution here. We have negative 2 that's going to multiply by each of these. So a couple things to worry about here. So first we have negative 24y, but then we have plus 18. Then we have minus 4y, or plus negative 4y. And then instead of writing minus negative 6, we can just write plus 6. Combining some like terms here, we're going to say negative 24y minus 4y is negative 28y. And then also this 18 plus 6 is going to be 24, so plus 24. So this right here would be the most simplified version of our original expression. All right, right away looking at A, this is already simplified. The constant terms do indeed match, however, these coefficients do not. So based on that logic, we can say this is not correct. All right, if you look at B just has 8y. Notice the coefficients don't match. Also, the constants don't match. There's technically a plus 0 as a constant for B, but we're not going to go ahead and say that's correct. Okay. For C here, I have a little, let's practice using that shortcut I kind of mentioned earlier. We have this 2y minus 3 here, but we have another 2y minus 3. Let's see, we have negative 4 of them, and we also have another negative 4 of them. So if you have an expression that looks like this, where the parentheses are identical, you can actually just go ahead and combine them, right? So this should save a little bit of work. This would be negative 8 of these 2y minus 3s. Right? And if you don't believe me, you can go ahead and check it. But if we have negative 4 of these things, and we have negative 4 of these things, we technically will have negative 8 of those things if you combine them. So it's a nice little shortcut if you notice that. And then you can just distribute one time, so it should save a little bit of time there. And you get negative 16y and then plus 24. So interesting. Looks like these constants do match, however, these coefficients do not. So we can, by that logic, say this is not equivalent. Here, notice for D, we have this 2y minus 3 again, another 2y minus 3 again, but we have negative 7 of them, but plus 15 more. This ends up being positive 8 of these 2y minus 3s, right? So again, you can save some time by combining those right away if they have the same, I guess, pieces inside the parentheses that are identical, right? So let's go ahead and distribute. If you go ahead here and you go ahead here, you're going to see that's going to be 16y minus 24. And it looks like the constants don't match as well as the coefficients don't match. So none of these work as well. Finally, for this last one, if we go ahead and distribute right away, negative 8 times 2y, that's going to be negative 16y, which we know is already wrong. And then plus 24, which is fine for the constant. So because these coefficients are not equivalent, we know that E also does not work here. So this one's a little bit strange, but it turns out that none of them are going to work. And so we could check this as well to plug in. I'm just going to do that real quick just because we didn't have to say anything where it's correct here. But if you plug in 2 into the original here, negative 28 times 2 is going to be negative 56. Negative 56 plus 24 is going to be negative 32. So you're going to notice that none of these are going to equal negative 32. If you plug in 2 here, that's going to be negative 32 plus 24. That can't equal negative 32. If you take 2 here, plug it in here, 8 times 2 is going to be 16, which is not equal to negative 32. And then if you go ahead and plug in 2 into each of these locations here, notice this is going to be 4 minus 3 is 1. 1 times the negative 4 is going to be negative 4. And then this is going to be 4 minus 3 is going to be 1. 1 times negative 4 is negative 4. This will equal negative 8, so that also doesn't work. If you plug in 2 here, 2 times 2 is 4, minus 3 is 1, times negative 7 is negative 7. Then 2 times 2 is 4, minus 3 is 1, times 15 is going to be 15. So negative 7 plus 15 is positive 8, which also doesn't work. Then this 2, plug it in here. That's going to be 4 minus 3 is 1. Negative 8 times 1 is going to be negative 8. So you can see here that none of these are going to work, even if you substitute in the value, which verifies that none of these are equivalent to the original expression. All right, so there you have a few different practice problems on identifying equivalent expressions versus non-equivalent expressions. Hopefully you found the video helpful. If you did, please consider giving the video a thumbs up and sharing with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.